Yeah, students, I welcome all of you. Okay, so today's session is about material handling hazards. So in this session, we are going to see what are the different types of materials the laborers are handling in an industry. So here the factors to be considered are: number one, the weight of the material; number two, the position, how they lift the material from one place and carry that same material to the other place. Okay, the way of doing work. And third, how many people are lifting that material. Okay, so while doing so, we are going to study the weight of material and the position of the places, starting place to the final place, and the movement of the labor along with the material load. So how these things are affecting the health of the labor. Okay, normally when you talk about the main part of the human body which is going to affect is the backbone. You know, the backbone, they call it as spinal cord. This is very important point. We will see one by one. Okay, let me go to the next slide. Yeah, you see, this is the spinal cord. This is the outline of a human body. You see, the people, we may be thinking the spinal cord is straight. It is not straight. This is the normal position of a man. The man is standing straight, but you see the spinal cord shape. It's a curved shape, right? So this is the main part when a man is lifting any products or any weight in a company. So directly the load transfers from his hand to the spinal cords. The spinal cords is having, you see, the dark color, the dark black color. This is called as the discs. There is a small discs between the two bones. So this disc is giving cushioning effect. Okay, this is like a shock absorbers in car or in automobiles. So this is how the nature, the God has created us. And when you carry a weight which is more than the limit, it may affect the disc. Okay, so the disc may get damaged, or the disc may get dislocated. It may slip from its position. So due to these things, he may get health problems. So how to solve this? So we can solve this by calculating the weight a normal worker or an average worker is allowed to lift. Okay, he should not lift more than that. This is one criteria. So let us see this outline and see the next diagram. So this is a detailed one. You can see this is the spinal cord, and of course this rose color one, this is called as the rupture, this is the disc, and this pale pink color, this is called the damaged, and these blue color ones are the nerve systems through which the blood circulates and keeps all the cells active in the disc. Okay, so this is very important factor. As far as the age is very small age, maybe around 25 or 27 or till 30, there will not be much problems. When age grows, this backbone problems is a major problem in an industry as far as material handling is concerned. Okay, now you see, this is the epidemiology of back injuries. There are acute effects. Acute effects means short term. This kind of effects will last for small duration only. Okay, this is due to sharp surfaces. If the sharp surfaces are hitting backside, sometimes, you know, you may get hit by some movement of materials, or some material may be dropped from some height. It may hit the backside, or struck by moving materials, or due to mechanical stresses. Mechanical stresses means, say for example, I will give you a small example of automobile or a car. If there is a tire is punctured, we will try to change the normal tire with the stiffening. So we try to unscrew the nuts from the tire. So we use the spanners. So this is the stress you give mechanically to remove the nuts. Okay, due to this some people may get back pain. Okay, this is one. And slips and falls. This is also another cause for giving short-term effects and simpler cause and effect relationships. There are so many cause and effect relationships which are very simple. Simple means it can be solved. Okay, it can be treated in 1 month or 2 months. Okay, that is called as short-term effects. It is also called as acute effects. Acute means short-term effects. Okay, let's see what is the long-term effects. See, epidemiology, this is a chronic effects. Chronic means it is long-term. Unfortunately, I have this problem. Always sitting in office, and you know, I'm more than 40 years, so it's difficult to stay with more loads constantly. Constant position will give back pain. Okay, so this is one backache. It is also called as back pain. Disc degeneration. Disc degeneration means the disc will lose its functionality. It will not function in a normal way. It will lose the capacity. Now what is disc? Okay, I will show you again the picture, the rose color one. This is the disc, and this is the disc. This is the disc. Okay, so disc degeneration and cause and effects not as simple. They are more difficult to analyze. So this kind of chronic effect, this kind of effects is called as chronic effects, and it will take lot of time, more than 6 months or so, to give the treatment. Okay, this is another health problems where you see around industries. He is working around some machines. He is supposed to lift material from there and here. So you should know what are the short-term effects, and it is also called acute effects. And second, you should know what are the long-term effects. It's also called as chronic effects. Okay, chronic effects are very difficult to treat, whereas acute effects are not much difficult. There we can call it as a simple to treat. Okay, and material handling. You see, this is how the man is. You see, this position is very, very wrong position. You see, his knee is here, and his position. You see, he is not taking any rest here. He is hanging his backside, and his bend. Everything is very wrong position. Definitely, it will give a problem on the back. Okay. Instead, he can kneel down. He can put one of his knee on the floor and take it. After that, he can move for one step and put it on this place. Okay, this kind of wrong positions is also another reason to get back pains. So you see, this happens because of lifting or lowering. Means lifting means taking up, lowering means putting down. Okay, and pushing and pulling. Pushing means, you know, making the material to come towards you, away from you. And pulling means making the material to come towards you. And carrying, of course, keeping activities. How many times he repeats, that is called frequencies. Is he doing this for 1 hour, or is he doing this for 2 hours? So that is called as frequency. And load, center of gravity. Center of gravity means if this is the box is having uniform load inside, the center of gravity will be at the center of the 2 diagonals. Okay, so you should hold accordingly. You should balance and hold the material. If you put one hand here, one hand there, it will not balance. That the material will shake. Because of this also, you may get problems on the body. So this is called methods of doing work. Number 1. And second, there is some human factors. You have studied the course called Human Factors Engineering, so we have to consider them. So human factors, ergonomics. Okay, ergonomics is nothing but comfortable working condition. That is called ergonomics. So we have to consider all these things. And sometimes, if it is required, you can redesign the workplace. If this kind of work is not good, then you can change the method. You can redesign the way of handling the materials. Okay, so these are the factors. Please go through this. And job risk factors. What are the factors which are related to the risk in a job. Number one, weight of the object. Of course, I told you already. Weight of the object should be limited. Number two, location means position of load with respect to worker. I'll just write with respect to. Let me choose some color. Yeah. WRT means with, okay, respect, RESPECT, with respect to. Okay, in short form they call it as WR, sorry, this is R and T, with respect to. So the position of load with respect to the worker. The worker and position, he should, the load should be at a reachable distance from the man. The man is here, the load should be here. This is the length of his hand. Okay, it should be at a reachable position easily. If it is little away or in a little awkward position, it's difficult for him to carry and move to other place. And next point is of frequency of lifts, means how many times he lifts in 1 hour or how many times he lifts in 2 hours. It's like that. And stability of the load. The load stability. Sometimes, you know, a box may have 10 kilograms. Sometimes it may have 11 kilograms. Some boxes may have, you know, the variable loads. It's not good. We should have a proper, constant load. That's easy for him to work for 1 hour. After that, another set of loads. Okay, for each time period. That is called stability of the loads. And hand couplings. Hand couplings in the sense he has to have a covered, he has to cover his hand, which holds easily, right? He will use some tools also. Sometimes we can use material handling hand tools. With the help of hand tools, you can use it. Say for example, if you have a big glass, very big glass companies are manufacturing, you know, our doors in the home, in offices, the doors are having single glass, huge size, 3 meters by 2 meters. It's difficult to handle it with bare hand. So there is a device, there is a tool which holds the glass, okay, with the help of suction, and rubber bushes. I will show you tomorrow when you come to my office. Okay, I have that hand tools. I will show you tomorrow. Okay, so we can use hand tools also to lift some kind of materials like glass, huge glasses and all. Okay, and next is about workplace geometry. Workplace geometry, twisting and stoopings. Workplace geometry, what is the other between the labor and the final point? What is this distance? So all these dimensions you have to measure and you can redesign. This is called about workplace geometry. And third is environmental factors. Environmental factors means the place around the labor should not have unnecessary materials or unnecessary moving vehicles. Sometimes automated guided vehicles, sometimes some forklifts may be moving around. So they should be little away. Okay, this is about environmental factors. These are all the factors you have to consider. Number one, weight of the object. Number two, location, that is position of load with respect to the worker. And number three is about frequency of lifts. Number four, stability of the loads. Number five, hand couplings. Number six is workplace geometry. Number seven is about environmental factors. These are the factors which may lead for risk in a job. Okay, and next, the examples of manual handling controls. How to control manual handling? Some examples I have given here. Number one, avoid extreme range of motion. Don't move more than required. Understand? If it is possible to keep the material in one hand distance, keep it there. Don't keep more than that. It's difficult for you to move and take. Okay, so extreme range, you can move but not extreme range. So extreme range you should avoid. Next, redesign the workstation. Already I told you this is called ergonomics factors. So you have to redesign the workplace or workstations. His health is not affected. Number 3 is about provide handles on material handling equipments. Okay, give handles so that the labor can use the handles while lifting the materials. If there is some materials without handles, if there is some boxes without handles, it's difficult to lift. So always in a box, say for example in the boxes, cartons, there are some holes. Okay, that hole is made particularly to hold it, to lift. Okay, such kind of provisions you have to make. And the next example is about to provide lift assist devices and tables. Lift assist, if the weight is more than which is designed for a labor, you can use some equipments like lift, okay, which helps to lift the products or the boxes. You can use such kind of equipment called as lift assist devices. There are more devices about this. You can search it as you like. And number 5th example is about unit load concept. Unit load concept means you have to maintain same load per unit of same type of products. So these are the examples you should follow so that we can control manual handling without hazards, without danger. Okay. And next is about job design. You see, it's easy. Now the material is kept on the table. It's not on the floor. The material is on the table. Okay, so he need not bend down to the floor to carry it. So it's easy. The workplace is redesigned. So this is going to minimize reach and lift distance. I told you in the previous slide, extreme range not good. So in the next slide they have minimized. This is very good. And keep off floor. Off floor means don't keep on the floor. Keep above the floor. This is called off floor. That means use some tables. Okay, use some tables so that you can keep the material over the table and lift it to another place. And workstation design. We are discussing this again and again in all slides. You have to redesign the workstations. And next, frequencies. Relax time standards. Time standards, because when a man is doing a job continuously, okay, normally his energy level, if this is a graph between time, if this and energy level, I write EL, okay, I cannot write here, so I just write EL. EL means energy level in y-axis. Initially the energy level will be more at the starting time, 0, when the time is 0. When time increases 1 hour, 2 hours, 3 hours, slowly the energy level of a man comes down. Okay, at one point he becomes more tired. He needs rest. Any human being needs rest. That is called fatigue. F-A-T-I-G-U-E. This is called fatigue. Fatigue means he gets more tired. He cannot continue his work. He cannot repeat. So when you are giving frequencies, means continuous working, give a relaxed time between some, maybe 1 hour or 2 hours. That depends upon so many factors like the weight of the object and the workplace, the environment, how he works. Okay, so based on that, the engineers or the managers can decide, okay, we will give him a relaxing time here. Again he continues, again give a relaxing time. So that the company can maintain the energy level at the same level from morning till evening, because we give him a break, relaxing. Okay, and also the work rest allowances, some 5 minutes or some 10 minutes. So like that you should give a work rest allowance. This is called allowance. It's not a main time. It's some allowance between continuous working. So these are the two things you should consider when you're designing a job. Designing in the job in the sense workplace, method of doing, everything. Okay, workplace design, a way of doing, methods. And again, minimize the weight. Don't increase the weight. Okay, these are all common sense, but still we are seeing it in a professional angle. Okay, so we have to minimize the weight. Use mechanical. How to minimize the weight? I cannot minimize because my company is producing a product which the minimum weight is 100 kilogram. Minimum weight is say 80 kilogram, 80 kg. I cannot reduce below this. So what to do? We cannot reduce the weight of the material below this level. So in that case, you can use mechanical aids. You can use the mechanical equipment to lift them. So then the labor, he will feel his weight is little happy. Okay. So then carton capacity. Control, there should be a limited capacity for each cartons because carton is having its own capacity to hold the load. If you put overload, the carton will break. So you have to design that. And balance contents. Balance content should be in another carton, right? That also should be designed. Next, convert. What is this about convert? You see, this is called as a method study. METHOD. This is called method study. How he is doing the work. I want to redesign the method of doing his work. Say for example, carry to push pull. Carry to push pull. Carry to push from pull. Say for example, there is one object here. Okay. The labor is here. If he wants to pull, see, he will use his full energy to pull it towards him. It's very difficult. It's very difficult. Pulling is very difficult in this direction towards the labor. So instead of that, we can tell this man, come this side, stand here. Okay, stand here and push it. Like this, okay, two hands. Push the material away from you, so the material will come to its place. So instead of pull, always prefer push. Pull is difficult, push is easy normally. Okay, so this is called carry to push from pull. Then push over pull. Yeah, of course, these 2 points are similar. And next is use large wheels. Use large wheels, because when you are having small wheel with a container, with a small container which has a small wheel, is it takes more revolutions in one time. It takes more revolution, means the wheel will rotate more time. Okay, instead of using small wheel, if you increase the wheel size diameter, it's very easy. In small push, the wheel will cover more distance. Distance covered will be more. So these are the small points we have to consider professionally and change the method of doing it. Okay. And next is about training. Of course, we have to give a proper training. We have to give a proper training here. How to handle the materials. Focus on awareness and avoidance. You should be more alert in lifting the materials, and you try to avoid which are heavy for you. And second is get the object as close to body as possible. Keep the materials in a hand reach. I already told you, in a distance which is equal to the length of a human hand. If the man is here, this is the distance. So keep the product here. Don't keep more distance. Okay, so keep it closer to the body. And next, plan properly how to do the work, means how to lift the materials, how to move it from one place to another place, right? And next is the use of handling aids. Handling aids means some equipments is used, some equipments are available. Using those equipments we can lift the materials. So the labor should get a training how to use these materials. Okay, this is one, use of handles. And strength and fitness is important. The labor has to be given enough training how to keep his body fit, because his job is just like a machine, because he is always lifting the materials irrespective of the ages. This man is he looks younger, he looks older, he looks maybe younger, I don't know. Anyway, so there are different age groups. All age groups may be working in the same shop floor, all have the same work. They have to lift the job. So the company should take care, and they should give enough training in how to keep their body fit to hold and lift the materials. Okay, these are the points as far as training is concerned. And now this is very important term, please. As far as engineers or managers is concerned in a company, they have to know what is all this. Number one, RWD is called recommended weight limit. This limit is good to work. Recommended weight limit. Number two is called LC. It is called load constant. It is one variable. Number three is called horizontal multiplier, another factor. Number four is vertical multiplier, VM. Number five is BM, that is distance multiplier. Number six is AM, asymmetric multiplier. Symmetric means same, asymmetric means it's different position, different weight, they are not same. That is why they call asymmetric multiplier. And number seven is FM, that is frequency multiplier. And number eight is CM, that is coupling multiplier. These are the different factors. Now we have to find what is this recommended weight limit. How to calculate recommended weight limit. Okay, once if you know the value of recommended weight limit, then we can tell the laborers this is the maximum load. Say for example, if RWL is calculated by these number 2, 3, 4, 2 to 8, if the value is calculated as say 40 kilogram, so as a manager you should not allow a labor to lift more than 40 kg. So recommended weight limit is 40. More than 40 is danger. It will cause health hazards if it is more. So this is the equation found long back before 20 years, still continuing. Okay, so you see RWL, recommended weight limit, is multiplication, is a product of all these variables which you have seen in the previous slides. It's a product of load constant, horizontal horizontal multiplier and vertical multiplier. This is distance multiplier, this is asymmetric multiplier, this is frequency multiplier, this is coupling multiplier. All these things you keep multiplying everything and you get a value, and that value is called as recommended weight limit. This very first you should find what is the value of RWL. I'll ask this in exam. How do you calculate RWL? And what is RWL? You have to answer RWL is recommended weight limit. How to calculate RWL? RWL is the product of this load constant, horizontal multiplier, vertical multiplier, distance multiplier, asymmetric multiplier, frequency multiplier, and coupling multiplier. That's your answer. Okay. Now how to find the guide? You see, we have to compare compare number 1 RWL, number 2 actual load. Actual load is represented by the letter L. Okay, you compare RWL with actual load. Actual load means the true load of the container or of the box or of the product. Okay, compare these two. So if the value is greater than or equal to 1, it is a problem for us. Equal to 1, somewhat okay. If it is greater than 1, it is a problem. So the actual load L should always be less than recommended weight limit. Okay, so if you calculate L divided by recommended weight limit, the value should be what? Less than 1. Then it is safe. It is good. If L divided by recommended weight limit is more than 1, it is not good. This is not good. It is danger. Okay. Say for example, I will show you next slide. This is called lifting index. Lifting index is nothing but L divided by, that is L is actual load. Actual load divided by recommended weight limit. If this value is greater than 1, say for example, L equal to 40 kg and recommended weight limit, it is equal to 43 kilogram. Okay, take it as 43 kilogram. Now what is L by RWL? This is L is 40, RWL is 43. So this is obviously 0 point some value, 9 or something. So this is less than 1. This is safe because actual load is less than RWL. Okay, this is good, no problems. But if L is 50 and recommended weight limit is 45, then what is L by what is the lifting index? L by recommended weight limit. This is 50 divided by 45. Obviously the value will be more than 1, maybe 1.01 something. Okay, this is greater than 1. So greater than 1 is very dangerous. That is why I write here, this could lead. I will take another color please. Same color is confusing you. Okay. So this could lead to health hazards. Which one? If it is greater. If the lifting index if the lifting index L divided by RWL is greater than 1, it will lead to health hazards if carried by a human being or by a laborer or by a worker. Okay, fine. So if the job is a hazard, what to do? Number 1, try to reduce the weight. If reducing weight is difficult, use mechanical assistance, use some equipments to lift it. Number 2, increase the weight of load so that you can increase the weight, but you use a mechanical equipment to lift that. Okay, don't make the man to lift. Next, reduce the capacity of the container. Okay, don't overload the containers. That is also another factor to be considered to reduce the job hazards. If the job is danger, you can take these 3 steps. Okay, and these are not the only limited steps. You can keep on including depending upon the nature of job and other things. Yeah, fine, that's it. This is a very simple topic we have covered. How to handle the materials in a company. The factors, the main body part which is being affected due to lifting of materials, moving of materials is the backbone. A backbone is more about spinal cords, disc, proper disc, damaged disc, disc degeneration, disc dislocation, and this is also depending on age factors of the worker. If some worker are young, no problems. If worker are aged more than 30 years, take care of them. Don't allow them to lift heavy loads. Put them in another section where the load of material is less. And also, if it is not possible to reduce the weight of a job, you can go for mechanical assistance to lift the job. Don't allow the labor to lift. And then also you can use hand tools to lift them, something like that. And then finally, before deciding the optimum load is nothing but recommended weight limit. That is the optimum load. And you know how to calculate recommended weight limit. The recommended weight limit is the product of load constant and so many factors I have shown you, product of all those factors. Once you find recommended weight limit, then compare with the actual load of the product and find the lifting index. Lifting index is nothing but actual load L divided by recommended weight limit RWL. If this value is less than 1, it is good. If this value is greater than 1, it is not good. It will cause damage to the health. Okay. So with this we are concluding chapter number 5. I have given some questionnaires. Say for example, which one of the following is acute effect? Acute means short term of back injuries. Disc degeneration, struck by moving parts, backache, pain. Get the answers. Which of the following? See the slide. I think number 2 or 3. This point I have given in the question. So this is struck by moving materials. That is the answer. So you see the slides and find the answer, and if it is difficult to get the answer, as usual you can get the answer from me in office time. Okay, so let us go back to the question. One more slide. Yeah, see number C, struck by moving material. This is the correct answer. So like this, which of the following is chronic? Chronic means long-term effect. I use the technical words, biological words. I don't use short-term, long-term. I use acute, I use chronic. Because as engineers or managers, you have to know what is acute, what is chronic. They are professional languages. Sorry, these slides are keep on moving. Yeah. Similarly, the weight of an object is a risk factor while lifting a material. Yes or no? It's obviously yes. And the position of load with respect to worker is a risk factor while lifting a material. Answer then. Frequency of lifts is a risk factor. Answer it. So you see and get the answer. And you see, as I told you, the equation of recommended weight limit. Okay, the first one, because there is a plus here. It is wrong. Okay, here multiply plus. It is wrong. There is no addition, no subtraction. Multiply. Yeah, third one is the correct answer. Fourth one also I give 1 plus. Okay, this is wrong. So go through this and get the answer. And with this, I am concluding today's lecture. All of you be online. I am taking the attendance. Probably from next week I will start the last chapter. Okay, that is very, very interesting and very important for all of you, because we are going to discuss about management responsibilities for safety. What a management of a company is taking responsibility to keep their workers safe. So this is very, very important. You have to know these informations. Okay, so we'll discuss this in next class. I will just taking your attendance, please be here. So today is 303.